Hello, let's continue our Advanced Sudoku series with Zoe's Puzzletime Funtime by Philip Newman. So this is puzzle number 4 of chapter 4 of the Sudokult Gospel document. As always, I know what technique I'm looking for and how to explain it, but I don't know exactly where it is in this specific puzzle. There is a link in the description if you'd like to try it yourself. There's also a link to the whole Sudokult Gospel document, just in case you don't know that, if you want to go through that yourself. And I'm going to get started right now. All right, I think we should get as much info as we can before we continue, do the technique, or look for it at least. So I'm not going to mark those 2s. We do have 5. 5s are up here somewhere. Boop-a-doo, 6, 5, 2. All right. 1, 2, 5, 9, 7. Okay. Not seeing anything there. We've got all these 5s looking down. So, 5 is placed. Very nice. We got a 5 there. No follow-up on that. There were 4 5s looking in. There's a 1 in one of these 2. These 2 4s look up, so we get a 4 in one of these 2. These 9s look down. We get a 9 over here somewhere. 3 and 3 puts a 3 in one of these 2. We have a 5 down here somewhere. We have 4s looking in, so 4's in one of those 2. All right, did I miss anything here? 1, 5, 3. 1, 5, 9. 9 actually is in one of these 2. That points left, putting a 9 in one of these 2. Okay. I've got these 2 3s, and then this 3 looks down, so there's a 3 in one of these 2. Let's see. Fours, 5s, 3s, 8s. Okay. Let's look vertically real quick. We do have 2 3s looking up, and this 3 looks in, so there's a 3 in one of these 2. There is, okay, we got the 4s, 1 and 5, 9. Two, 3, 6. Okay. And then over here we have the 9s. Okay, I think that's all the basic scanning. Forgive me if I missed something. Let's see, what else do we have here? This can't be 1, 2, 3, 4, 5. This can't be 1, 2. It could be 3, 4, 5, 6. So this can be, it can't be 1, 2, 3. It can't be 4, 5, 6, 7. So this is only from 8, 9. In general, okay, this sees 1, 2, 3, 4, 5. We have a bunch of cells seeing 1, 2, 3, 4, 5. This sees 1, 2, 3. No. This sees 1, 2, 3, 4, 5. All right. So yeah, we should be suspicious of 6, 7, 8, 9 here. All right. I think I'm actually going to look for the technique now. I'm going to explain this the traditional way, and then I'm going to explain it in a different way, which is interesting. We went all over this in the Sudokult discussion episode, one of them. So now is the time if you still wanted to try the puzzle yourself, but I'm going to go over what the technique is. So what we're looking for is a junior exoset, and actually it's labeled as a double junior exoset. We'll see what that means. But a junior exoset. So if you're looking for one of those, one of the telltale signs that Philip says to look for, which I don't know if always happens, but I think it's pretty frequent, is you want a grid of givens like this. I'll just put those in red for a second. So you've got kind of this 3x3 grid of givens that all avoid an entire stack or band. In this case, they're avoiding an entire stack. So when you have this grid, that's kind of the easiest way to set up an exoset. Apparently exosets happen a lot in puzzles. Like you can almost always find one, which is interesting. I don't know if that's 100% true, but it seems like they're one of those advanced techniques that are kind of a last resort advanced technique. But anyway, so let's go over the exoset here. So what we're looking at here is we're going to be looking at these 3 rows that these givens are occupying. So let's get rid of the red. And actually, I'm going to mark these rows in blue. I'm going to write the whole row in blue, actually, just to start with. I'm not going to go over all the terminology. I'll probably get some of it wrong. I'll go over some of it, but here's what we're looking for. We're going to pencil all of these cells just for convenience, but honestly, we don't need to, because let's point out this 6, this 9, this 8, and this 7 here. So we also have this 9 here, which may or may not be important, but because these all involve 1, 2, 3, 4, 5, right? In the blue, we've got 1, 2, 3, 4, 5. In fact, just in this grid, we've got 1, 2, 3, 4. What we're looking at is we're looking for 6, 7, 8, 9. And in this case, in the blue, this is kind of the beginning of our setup. 6 can only appear twice, because we only have 2 columns that can have 6. 7 can only appear twice. 8 can only appear twice, and 9 can only appear once, actually. Actually, 9 can't appear. 9 can appear once, right here. That's it. So the point is they can't appear 3 times, but there are 3 rows. So we're going to need 6, 7, 8, 9s over here. Now, here's the key. No, remember when I said some of these cells were down to just 6, 7, 8, 9? This one was one of them. 1, 2, it sees 1, 2, 3, 4, 5. So this cell's also down to 6, 7, 8, 9. That's going to be important. I'm going to mark these in purple. Now, these purple cells are what we're going to use as our base cells. Now, our base cells, here's the important bit. We know that at least one of each of 6, 7, 8, 9 need to appear in these 6 cells. And these base cells here are going to have 2 of those. We don't know which 2 they are, but we'll call them the purple ones. So the question is, how do we put 2 purple ones into blue in here? And so I'm going to get rid of the blue at this point, and I'm going to say, okay, how about in here? How do we put one of each of the purple cells? Well, the answer is they can't repeat in the box. They can't repeat in the column. So they can only go here. And so the conclusion is these are the base cells. These are the targets of the base cells. These are the targets, and the targets can only be 6, 7, 8, 9. They can't be anything else. Because if they were anything else, we wouldn't be able to put enough 6, 7, 8, 9s into these 3 rows. So that's the first conclusion. So we have the base cells, we have the target cells. And so the target cells are the same purple digits as the base cells. Now, the next conclusion we can make is that we have kind of these companion cells here. I believe it's this one and these 2. So let's look at what these 2 cells can be. Actually, I don't think it matters. So let's make these in orange. So the thing to think about here with the companion cells is whatever this one ends up being. Let's actually give this a gray. This is the purple gray, and we'll call this one the purple black. I don't like black. Let's call this the purple green. Okay, so we've got purple green and purple gray. So where does purple gray go in this box? Well, there's another purple gray up here somewhere. So it can't go here. Purple gray can't go here, and these aren't purple gray because these have to be different. These have to be the 2 purples here, one of each. So purple gray goes here. So this orange cell here, what's called a mirror cell, actually ends up being the purple gray cell. So this is also 6, 7, 8, 9. Now here's the key. It can't be 9, and we know it's mirrored here, so this can't be 9. So we have a first elimination. And actually, we already had some eliminations because these could only be from 6, 7, 8, 9, right? Now, purple green, we have the same thing. It's up here somewhere. There's a purple green up here. So they can't be here. So one of these orange cells is going to be the purple green cell. We don't know which one, but purple green goes somewhere in here. And now the question to ask is can either of these not be 6, 7, 8, 9? Let's just pencil these. It looks like they can be 1, 2. Can't be 3, 4, 5. They could be 6, 7, 8, 9. That's not 8, 9. Okay, so it looks like it could be either of these at this point, at least. Okay. And so now, actually, let's think about these cells. Okay, so what's interesting about these cells is they see 1, 2, 3, 4, 5 already. So these are also from 6, 7, 8, 9. That's not 8, 9. So we know that, yeah, we have a quad now because these are 6, 7, 8, 9, and then the purple green is 6, 7, 8, 9. It's in here somewhere. So this can't be from 6, 7, 8, 9. So it's not 1. It could be 2. It's not 3, 4, 5. It's not 6, 7, 8, 9. So we have a naked 2 here. So we get a 2. Very nice. The That's almost a pair. Interesting. Okay, so what else can we conclude? This was also 6, 7, 8, 9. It sees 1, 2, 3, 4, 5. In fact, these are just from 6, 7, 8, 9. That makes another 6, 7, 8, 9 quad here. So this looks like 2, 4 pair. Now this cell here, in fact, what are these two? Well, hold on. This one sees 1, 2, 3, 5. So this is from 4, 6, 7, 8, 9, not 9. And this one sees 1, 2, 3. This could be from, it can't be, okay, it can't be 4 because of the 2, 4 pair. So it can't be 1, 2, 3, 4, 5. This is from 6, 7, 8, 9. Okay, it's not 9. And let's see, what other eliminations can we do here? Up here? We know these involve a 3. 1 in this column goes down here. It's interesting. Okay, so interestingly, what we know is that because the 1 is limited to down here, one of these is 1, and then the other one is the purple-green. So if we limit purple-green, we can also limit these, because you know the other one's the 1. These are 3, 6, 7, 8, 9, I think. They can't be 4. Okay, so 4 in this box is placed. This is a 4. That's convenient. And these are 3, 6, 7, 8, 9. Clean up a little bit. Okay, and that 4 gives us this 4. Okay, now before I get too much further, I think this is enough to solve the puzzle. But before I get too much further, I'm going to show the alternate way to look at exosets, which I think can be a little bit easier, especially if you're used to set. Sometimes viewing it as a set can really help you get those deductions like one after another. It's going to feel very similar, but anyway. So let's back up all the way to and the deductions will be a lot easier to think about. I don't know if they're necessarily better deductions than what we had, but they are certainly going to be easier to think about, I'm assuming. Okay, so yeah, so we don't need these reds here anymore. This is when we started thinking about the exoset. All right, so we're going to use these same 3 rows. We're going to do set. So we need to find 3 columns. So the givens that we've got in these are 1, 2, 3, 4, 5. We've got a stray 9 in there. So 1, 2, 3, 4, 5, 9. So the what we're interested in though is pretty much 6, 7, 8, 9 because we got majority 1, 2, 3, 4, 5. So we want to pick the columns that will bring in 6, 7, 8, 9s. And so this column, and this column are probably the best we're going to get. And notice that those are kind of the fishy columns that we used before. So this will feel natural. And then we can eliminate these. So we know that this is a balanced set. So the blue cells and the orange cells have the same digits as each other in them. I can do some eliminations. I can get rid of these 9s. I can get rid of all of these 5s here. Very nice. So we still have a stray 5 in blue, but orange just has 6, 7, 8, 9. Okay. So what do we learn about what needs to go in blue? Well, blue needs 6, 7, 8, and 9 in it. That's the conclusion, because it doesn't have it yet. Well, we found one of the 9s. It's over here. But yeah, we need to place 6, 7, 8, 9. They can only go here. So 6, 7, 8, 9 is 4 digits that have to go into these 6 cells somewhere. But if you remember, this cell here, when we penciled it, it was 6, 7, 8, 9. And also these cells over here are 6, 7, 8, 9. They see 1, 2, 3, 4, 5, right? So let's start up here. Let's make these 2 purple, and we'll make one of the, we won't make one of them purple gray, but these 2 end up purple. So we need one of each of 6, 7, 8, 9. This is going to feel very familiar to the exoset, but we've kind of proved it in a different way. We need one of each of 6, 7, 8, 9. And so these purples are 2 of them. And so where do the purples go in blue? Well, they can't go here and they can't go here. So that means that these have to be the purples and they have to be one of each of the purples. And so they have to be from 6, 7, 8, 9. Additionally, we have these 2, which we'll call greens. And notice these are different. So we'll call this one the purple gray. Actually, we shouldn't use green down here. And we'll call this one the purple green. And then down here, let's just make these, I don't know, let's pick red. So these 2 are red. I don't like red. Let's do yellow. So these 2 are yellow. And these are the two yellow 6, 7, 8, 9s that can't go here and can't go here. So where do the two yellow 6, 7, 8, 9s go in these cells? Well, they can only go here. So these are the yellow 6, 7, 8, 9s. And I can make one, let's make this one gray, this one green. So actually, this is a 6, 7, 8, 9 quadruple, which we didn't really realize from our exoset when we did it. Maybe that's what the double exoset's supposed to be implying, that maybe we could have used the exoset from down here as well. We didn't really have to, but we could have. And so now we can still ask the questions of like, where does purple green go in this box? It can only go here. So this is purple green and it's 6, 7, 8, 9. And then we can still ask the same question of where does yellow gray go? It goes up here. Where does purple gray go? It goes down here. We're not too worried about that right now. You can get those conclusions. Knowing this is a quad is really, really helpful. Because now we know this can't be 9, right? Because it has to be the green one, but also because there's only one 9 in this quad and it's here. What about these two cells though? So here's the question. Right. It's not even a question. These can't be 6, 7, 8, 9, right? Because they see the 6, 7, 8, 9 quads. Right, so I guess it's even easier to see that. We see two purples, 2 yellows. This sees 2 purples, 2 yellows. And then this sees, let's see, how does this one see purple grays down here? So I guess we have to use that. But anyway, these can't be 6, 7, 8, 9 because we know where the 6, 7, 8, 9s ended up. And they aren't here. So this can't be 1, 2, 3. This can be 4. Can't be 5. Can't be 6, 7, 8, 9. So this is a 4. And I believe this one ends up at 2. 1, 2, 3, 4, 5. Yeah, this one ends up at 2. So now here's the conclusion we can make. There is exactly, okay, well, hold on. We can get this 4 if we want. But anyway, the conclusion is there is only exactly one. Remember, these were blue? There's only exactly one 6, 7, 8, 9 in blue. One of each. So orange cannot have more 6, 7, 8, 9s. So we can actually go to every single one of these orange cells. And we can fill them with 1, 2, 3, 4, 5. Because they can't be 6, 7, 8, 9. And then so this is not a 9. That places this 9. And we can clean this up quite a bit. I'll just clean them up based on Sudoku here. This is a naked 1. This is not 1, 3, 5. This is not 1, 5. This is not 1, 4. This is not 1, 4, 5. This is not 2, 5. So you can see that we may have been able to figure out those eliminations without set, but set just made it so easy just to immediately think about. This ended up a 2, 4 pair, if I recall. So I think this needed to be a 6, 7, 8. All right, this is just 6, 7, 8, 9 naturally, now that we got the 2, 4. So this ends up being the, it looks like it's the yellow green. And so this is a 2, 4 pair. Now we'll solve the puzzle from here. Okay, what can we do here? This cell sees 1, 2, 3, 4, 5, 8, 9. So this is a 6, 7. That makes a 6, 7 pair here. So this cell sees, actually, that leaves a 1, 2, 4 triple. So this sees 2 and 4. So this is a naked 1. These aren't 1s. That puts a 1 here. This isn't a 1. That's not a 1. I'm not sure I need my set colors anymore, but we'll just leave them. It's fine. This is our other 6, 7, 8, 9. So this is our mirror. This is our purple dark gray. Okay. And so this is 3, 6, 7, 8, 9. I'm wondering if there's another pair or something that resolves this, but I'm not sure. Let's see what we can do here. We just got a lot of info, and I'm not sure where to go next. Maybe this box, which does need a 1, which goes over. Oh, the 1 is placed here, and then we need 1, 2, 3, 4, 5, 6. We need 7, 8, 9. Okay, that sounds helpful. Almost a quad. Not quite. What else do we have here? Oh, the 9 was in one of these two. So this isn't 9, right? And that's the mirror. Okay, so we knew that. Not so exciting, actually. This column needs a 3. Yep, and the 3 can only go here. That's not a 3. So this is a 2. That's a 3. This is 7, 8. This is 6, 7, 8. Not an 8. We get down here. We get the 5. This is 6 or 7. This is 6, 7, 8, 9, not a 9. So the 9's over here. Kind of need that from the box. This isn't 5, so we can place the 5. 2, 3 pair means this isn't a 3. So this is our other 6, 7, 8, 9. So this is the yellow gray 6, 7, 8, 9. Now, what do we know about yellow gray? Nothing. Okay. Wonderful. We still don't know what colors these are. The 2, 3 pair gives us this 4. We should know what this is. It's a 3. Nope, I'm wrong. Oh, I made a mistake somewhere. Because this can't be a 3. We lost the 3 in this row. So when did I do that? The 2, 3 pair somehow did that. Or was it? Yeah, what caused this 2, 3 pair? Getting the 5? I'm not sure how far back to go. 7, 8, 9. That's not 9. Cleared that. Got this 3 for the column. No, because it's not a 3 for the column. That was my mistake. Okay. Whoops. Making dumb mistakes. So we need 2, 3, 7, 8 here. 2, 3, 7, 8. That's not 2, 3. That's not 2. So we have a 7, 8 pair here. So this actually is a 3 though. Are we still broken here? That's a 3. That's a 5. We're broken already. Because now we... Okay, well, hold on. If this is... Did I like make a mistake with this 2, 3 pair? Because this isn't a 3. That makes this a 3. Maybe I just messed it up over here. So that's a 4. This seems to work okay. This is 8 or 9, so 8. That's 9. So now we know that one of our purples is 9. So that has to be the gray. So these are 9s. Cool. This is a 2. This is a 4. That's not a 5. Okay, I must have just made a really dumb like typographical error earlier. Whoops. All right, that's 4. That's 3. That's 2. That's 4. This we know is the purple gray now, and this is the purple green. That's good to know. And this is the yellow gray. Okay, might as well keep up with that. We know these two are one of each of the purple and yellows. In fact, 9 has a name now, so we don't have to call it purple gray anymore. Let's get rid of that. I'm sure this just finishes with penciling. This is a 5. These are... We know we need a 1, so the 1 goes here. And this is 6, 7. This is 6, 7, 8. It's not 7 or 8. Okay, the box is done. That's a 6. So yellow green is no longer 6. What else do we have here? This triple. 1, 2, 3, 4, 5. We need 6, 7, 8, 9. Okay, not surprising. Here we need 6, 7, 8. All right, we get the 6. We get that's not 6. All right. So yellow is a 7, 8 pair. So this has to be 7, 8. That's a 6. This is 6. And that's 6. Okay. That's not 6. This is the 6. All right. So all the purples are known now. We don't need to color those anymore. We get our 7 and our 8. That gives us 7 and 8. So that's a 7. That's an 8. And now we have all of our exoset digits done. I think our entire set is done, in fact, so let's just get rid of that. And we get the 7, we get the 9, the 6, the 8, 8 and 9. Here we need a 7 and 8. Is that not resolved? No, it must be. Yeah, that's 7, that's 8. This is a 7. This is 2, actually. And we need 6 and 7 here. That's 6, that's 7, and we got the correct solution, finally. Not finally, but like, I made a couple mistakes, but... Yeah, so let me know if you liked the traditional exoset way of seeing it or the set way of seeing it. I feel like the set way, if you're familiar with set, feels a bit more natural, and we were able to just like really pump out the deductions there. But you still have to do the sort of exoset-y thing of discovering, here we had it twice, that these cells could only be 6, 7, 8, 9. And that affected where they could go. They kind of acted as like exofins. I don't know if that's the right term, but that's the term I'm going to use right now, where these were strategically placed such that they couldn't end up in any but 2 of the remaining cells in our blue. So that's the key deduction to all exosets is that you need those digits and they can't go in most of the places that you think they could go. So coloring really helps there too. I hope you enjoyed this. I hope you found it interesting. If you did, then why not leave a like, subscribe, and a kind comment below.